In this video, we're going to go over bitwise operations in Python. We're going to go over ands, ors, XORs, nots, left shifts, and right shifts. The time codes will be in the bottom if you want to jump between. Bitwise operators are actually super useful for a few different types of things. For instance, bit fields or like flags. So for instance, say you have some set of permissions that you could read something, write something, do something else. So if somebody has all of the permissions, which would be a 3 bits, which would be a 7, then you just do a bitwise and on that 7 on their permissions, and there you go. That's it. You're done. Now you know if it's true or not, because if it's still equal to 7, then they have all the permissions. While that might seem really strange, that's actually one of the best ways you can do it because computationally, it's extremely fast. Another thing you can use it for is communications over ports and sockets, types of compression and encryption, and things like finite state machines or graphics. To start off, let's quickly look at how you can view binary in Python. So here we have var1, and we have an integer, and we're passing in a string, and this is the base. So base 2 just means that it is going to be binary. So this 0, 1, 1, 1 is 7, and 0, 0, 1, 1 is 3, because this is a 4. So you're just adding the 4 to these ones. Cool. And then I have this little helper function here, which will print out the binary itself. So if we run this, we can see that we get a few extras here, but we get 7, we get what the 7 is, and then we get 3 and what the 3 is. Great. So let's move on to ands. I have all this written out already, so we'll uncomment this. So let's run this and talk it over. So the ands are seen right here. So we have var1, which is a bunch of zeros, and 1, 1, 1, which is the 7, and then a bunch of zeros and 1, 1, which is the 3. And the result of doing an and is basically the 3. The reason for this is because anytime there is a 1 in both of these, then a 1 is the result in that space. So there is a 1 in the ones column. You can call it a column in this view because there is a 1 in both the 7 and the 3. There is a 1 in the 2's column because there is a 1 in both the 3's case and the 7's case. There is not a 1 in the 4's column because there is not a 1 in the 3's. So I hope that makes sense. So basically, there's 1s here because there's 1s here and 1s here, but there's not a 1 here because we don't have 1 here. So we're printing out the result here, and it is a 3. So if we added a 1 here and made this 7 and 7, then it would be 1, 1, 1, which would be 7. That's it for ands. Pretty simple. Okay, moving on to ors. Let's get rid of these, and let's print this out. Okay, ors. Well, you can kind of see like the ands, it's the similar thing. We have 1, 1, 1, 1, 1, so the 7 and the 3, but this time we do have this 1, because an or is it true in one case or the other case? So is there a 1 in one case or the other case? So because there's a 1 here in the 7, and even though there's not 1 here in the 3, we still get the 1 here for the result. So the result here is equal to 7, which basically just means this case. Yeah, pretty simple. If it's in one or the other, then add the 1. Nice and easy. XORs. Let's uncomment this and give it a run. Okay, XORs. XORs is basically if it is in one of them, but not in the other. So in the 7 and 3 example, we have a 1 right here for just the 4, because the 4's column, there is a 1 there in the 7. This is the 7. Remember, var1 is 7, but there is not a 1 in this column for here. Notice that the zeros still are the same. So this is an XOR is when basically it's in one, but not in the other. In this case, we only have the 1 here. So if we change this around, let's do that and see if we get any different results. Okay. You can see we do actually get the exact same result because it doesn't matter which one you're printing first or which one you're comparing. It's only the differences. Cool. Let's just undo this. Excellent. Now let's uncomment the not. So we're going to keep this part commented just for a second, and I'll explain why in a sec. So let's print this. Bitwise not. So we have a 10, right, which is the 1010. Then we do a not on this 10. So what a not actually should be doing is it should be flipping all of the ones to zeros and the zeros to ones. Pretty simple. However, what you might notice here is that when we do this, when we do our not and we print out our var3, we don't actually, we're binifying our var3, but we don't actually get the right number we're kind of expecting here, right? We get it minus 11, which is not correct. So the reason for this is actually a reason for how Python implements integers. Python doesn't actually leave a bit to represent negative. So the very leftmost bit in a 32-bit integer is typically how an integer is determined whether it's negative or not. And in this case, Python doesn't care about that last bit. It just lets it be a normal bit. So we actually have to do something in order to get the correct value here. We have to use something called a bitwise mask. So if we get rid of these here, what a bitwise mask is doing is it's basically just anding an example or an integer where everything is a 1. So only the cases where this would be a 1. So basically it's flipping all of the zeros to ones. So you could think of this as like a bunch of zeros and then 0 or 1 0 1 0. But if it's flipping all of it, it'll be a bunch of ones 0 1 0 1. So this is just anding it so that we actually get the correct result there. So if we print this off, we can see our result here. So we have our 4 ones and then a 0 1 0 1. So the result of this is actually 245. So you can actually kind of see that it's like basically the difference between 255, which is what we did our mask on, and 10. 255, just to be clear, is actually the size of all of these put together. So if all of these were ones, that is what 255 is. Cool. We've done knots. Now let's go over what a left shift is doing. So let's run this. So a left shift, pretty simple, is just shifting any of the bits to the left. So here we're shifting it to the left. So we have a 7, we shift our bits to the left. We're saying that we're gonna shift them by 1, and then we now have a 14. If we shift them by 2, we can see we get a 28 because these 3 bits have moved to the left twice. Now you can see we can get some strange behavior here. If we do a lot more, we can get 448. What if we go by 10? Okay, what if we go by like 60? Weird result, right? Pretty weird result. So this is actually like correct because again, because Python doesn't care about the negative integers. Yeah, it's a little bit crazy because this is a number that would overflow an integer very easily. Because in one of the last videos we talked about, an integer is basically blocked at 2.1 billion, I believe is the upper limit typically. Cool, but that's a left shift. A right shift. Well, you can probably guess what the right shift is based off of the left shift. We are now shifting things to the right. So if we have 3 here, we are shifting them to the right, and you may actually notice that, wow, look at that. Where'd the other one go? It is gone. That's right, if it falls off the end, it is just gone. Dead. So yeah, here, if we move this so that we have a 1 here and a 0, we can see that they shift just like that as well. That's it. You now have a basic idea of how to use bitwise operators in Python. Remember, I'm Jake, You're awesome. And this has been Bitwise Operators in Python. Thanks for watching. Cheers.